algebraic proofs, and like I said, we're going to be looking at some different properties, all right, that you use to solve equations, and then some other properties that just are mathematical properties. The first four that we're going to talk about is the addition, subtraction, multiplication, and division properties of equality. And basically, when you solve an equation, what you do to one side, you do to the other, right? Okay? So if I have an equation, I can add the same thing to both sides, and it doesn't change it. So if I looked at this equation, x minus 2 equals 5, what would I do to solve it?
Add 2 to both sides.
Add 2 to both sides, okay? Look at the next one, y plus 6 equals 11, what would I do?
Subtract 6.
I would subtract 6. That's the subtraction property, okay, from both sides. Okay, what if I have x over 5 equals 2?
Multiply.
Then I multiply both sides. That's the multiplication property. And then 7y equals 42. That's, we have to divide both sides by 7, and that's the division property. So you're familiar with those four properties. Now, another property is the reflexive property. It's not one that we use a lot, but basically it says that one side of the equation is equal to the other. It's like a reflection or a mirror image, all right? So A equals A. The length of PQ equals the length of PQ. That is the reflexive property. The symmetric property you use all the time, you probably don't realize it, but you use it all the time. The symmetric property allows the two sides of the equation to switch places. So if A equals B, then B equals A. If AB equals CD, then CD equals AB. All the time you solve equations, when you get to the end, you might have 2 equals x. But then when you go to write the answer, how do you write it usually? X equals 2. So that is the symmetric property. Okay, that is the symmetric property. Then we have the transitive property. And the transitive property, I think of it hooks together like a train. Okay? If A equals B and B equals C, then A equals C. So if A equals B and then B is equal to the third number, then A is equal to that third number. Okay, it's kind of like the law of syllogism, except for the law of syllogism uses if-then statements, and the transitive property uses equations or congruent statements. Okay, so here's an example. If AB equals CD and CD equals 8, then AB equals 8. Okay, that's transitive. Goes together like a train. Then we have the substitution property, which sometimes people get these two properties confused. And they're similar. But the substitution property, if A equals B, then A can be replaced by B in any equation or expression. And I changed this from what's on your notes. If AB equals 7, and AB plus BC equals CD, then 7 plus BC equals CD. So what I have is, AB equals 7. And then in this problem I have AB. And then I rewrote it and I replaced AB with 7. That's replacing something with what it's equal to. Okay, that's substitution. And then we have the distributive property. The distributive property is when you distribute a number over a sum or difference and you multiply when you do it. So 3 times x equal plus 3 times 5, so it ends up being 3x plus 15. Okay. Alright, so we're going to go through here and we're going to state some of these properties. Always ask yourself, what did they do to the if to get to the then? What did they do to the if to get to the then? So we have AB plus BC equals DE plus BC. Then AB equals DE. What did they do to the if to get to the then? Yes. Okay, they subtracted BC from both sides. Whatever you do to one side, you do to the other. Okay, and when they did that, they got AB equals DE. So that is subtraction. Okay, here's another one. If XY equals PQ and XY equals RS, then PQ equals RS. This would be the transitive property. Would be symmetric. Symmetric flip-flops places. Okay? The order's a little wonky here, but it still works. Right? So this right here would be the transitive. You can flip-flop this one using the symmetric, and then it kind of flows a little bit better. Okay? But you can just call the whole thing transitive. Alright. If 1/3 x equals 5, then x equals 15. That's multiplication. Alright? Measure of angle ABC equals the measure of angle ABC. That's reflexive. Okay, if 2x equals 9, then x equals 9 halves. Okay, that would be division. Alright, here's another one. If the measure of angle 1 equals the measure of angle 2, and the measure of angle 2 equals the measure of angle 3, and the measure of angle 1 equals the measure of angle 3. I would take substitution. It's really truly though what? That's transitive. That's not transitive. I would take substitution. Because that's the form. I'm going to call it transitive. Alright. So we're going to do a few of these algebraic proofs. Okay? When you do a proof, you have some information. Yes. Okay? The transitive has an order really to it usually. Okay? So like if angle 1 equals angle 2, and then you repeat, okay, angle 2 is equal to the third thing, and angle 1 is equal to angle 3. Typically your substitution, like you have two things that are equal to each other, and then you have another thing, and you go in and replace that with what one of those things are equal to. It's like replacing something with what it's equal to. I'm pretty lenient on the difference between the two. Usually the transitive works with more like it's more like groups of things that are being grouped together. Your substitution, like if I said x equals 2 and y plus x equals 6. If x equals 2 and y plus x equals 6, and I can say y plus 2 equals 6. That's substitution. Does that help? Okay. Alright. Alright, so we have these proofs. And in a proof, you have given information. This is like the gospel. You can't dispute it. It's true. Okay? Then you have what you want to prove. Alright? And so what your job is to make a logical pattern or step of events that gets you from the given to the proof. Okay? You have to make a series of steps that takes you from one to the other. Okay? And so you always start out by writing the given. That's your first step. Your last step is always what you're trying to prove. So you have 3 times the quantity, x minus 5/3 equals 1. That's given. Alright, so if you were going to solve this, what would you do? You would distribute the 3, right? So, you distribute the 3. Okay, and then you write what you did to get to that step. What you did to get from that step to the next one you distribute it. Okay? Alright, now what would you do?
Add 5.
Add 5 to both sides. So you get 3x equals 6, and you did that by addition. Then what would you do?
You divide by 5.
Divide both sides by 3, and so you get x equals 2, and that is division. And so we proved what we were set out to do. Alright? And we justified every step. Alright, here's another one. 7 halves minus n equals 4 minus 1/2 n. And that's given to us. Okay, what do we not like about this problem?
Fractions.
Fractions. So what might we do to get rid of those?
Multiply by 2.
Okay, we can multiply both sides by 2. Now, the next 2 steps, most of the time you guys do is one step. It's really 2 steps. So we're going to multiply both sides by 2. And we're going to put multiplication right there. So when we actually multiply, what are we actually doing? No,
Distributive.
Distributive. Right? We're actually distributing the 2 now. So that'd be 7 minus 2n equals 8 minus n. And that's the distributive problem. Alright, now at this point, we might take different paths. Because the way way you solve an equation might be a little bit different than the way I solve an equation. Okay? So what would you do first? What? Okay, you want to bring n over to the left, so you have to add n to both sides. Okay? So that would be 7 minus n equals 8. That'd be addition, right? Okay, then what would you do? Subtract 7 from both sides. That's negative n equals 1. And that is by subtraction. Okay? And then what would you do? Multiply or divide, right? Either one would work. By negative 1. By 1. And there's your answer. Now, how many of you would have done something a little different right here? What would you have done?
Probably put it.
How many would have moved the 7 over to begin with? Okay? I want to show you how it can look a little bit different. Okay? Every hour except this one, they say minus 7. That's the first thing they would do. So, okay. Negative 2n equals 1 minus n. And that would have been by... Okay, so from here to here, they got negative 2n equals 1 minus n. And that is subtraction. And then they added n to both sides. So that's negative n equals 1. That's addition. And then they divide or multiply by negative 1 for the same reason. Okay. So, like I said, because we all solve equations a little bit differently, yours might look a little bit different from theirs once you get to this point. Okay? Depending on how you choose to solve. Alright. That's basically what you're going to be doing today. Now, I want to show you some other ones that involve a little bit more geometry, because those are going to be coming starting Friday and Monday. Okay? And so we kind of want to ease our way into it. But we all know how to solve the equation, so I'm going to stretch your brain just a little bit and add a little bit to it. Alright, so again, you start out with your given. AB is congruent to CD. AB equals 2x minus 5, and CD equals 4x minus 13. And that's given. Okay. Now, we can see we have information about AB, and we can see we have information about CD. Okay? And so, really, if you think about it, we can go and replace both of these. But you can't replace, you can't use substitution when you're in the congruence mode. So you have to change this congruence statement into an equality statement. And we can do that because we know if two things are congruent, they're equal. If they're equal, they're congruent, right? The definition of congruence allows us to say that. So I'm going to take this little statement right here, and I'm going to rewrite it as AB equals CD. And the definition of congruence allows me to do that. Okay? And so then, now what I can do is I can see I have AB is 2x minus 5, and CD is 4x minus 13. I can replace those with what they're equal to. What's that called? Substitution. Alright, so we have 2x minus 5 equals 4x minus 13. Alright, and so that would be substitution. And then what would I do? Then you would start solving. Okay? And so, what would you do first? Okay, you're going to subtract 2x from both sides. Okay? So that gives me negative 5 equals 2x minus 13. And that's subtraction.
Add 13.
Okay, then we're going to add 13 to both sides. We have 8 equals 2x, so that's addition. And then what are you going to do?
You divide.
Divide both sides by 2, so make it 4 equals x. That's division. Now what's wrong with this? It says I need x equals 4, but I have 4 equals x.
You can use the symmetric property and change it to
Perfect. Use the symmetric property and switch it around, right? Good. Okay. Here's another one. Alright, now this has a lot of givens, so I'm going to go ahead and write the given down and then we'll talk about it. Okay? So angle FGJ is congruent to angle JTK. Angle JTK equals angle KGH. And the measure of angle FGJ equals 6x plus 7. And the measure of angle KGH equals 8x minus 5. Okay, so I wrote my given down. Now let's talk about what the given says. You always want to read the given and go and mark your picture of it if you can. Okay, so it says FGJ, which is this angle right here, is congruent to JGK. Then it says that JGK is congruent to KGH. What might we get from that? They're all congruent to each other. So could I connect this angle right here with this one and say FGJ is congruent to KGH? Yes. And what property allows me to do that? Yeah, you could, but you look at the order which is stated. FGJ is congruent to JGK. Repeat, JGK is congruent to KGH. That would be probably more transient. Alright, now see how I have information about FGJ and information about KGH. What do I need to do here before I can do anything with that? I am going to substitute. But remember, before you can substitute, you have to use definition of congruence and change it to equals, right? Okay. So now I'm going to have the measure of angle FGJ equals the measure of angle KGH. And remember, that's definition of congruence. Now what can I do, Connor? Now I can substitute. So now I can replace FGJ with 6x plus 7. And I can replace KGH with 8x minus 5. And that is substitution. Alright, so now we're in business because now we can just get on with solving our equation, right? Okay? Alright, so Samson, what do you think we should do? What did you say? Addition, so you're going to add 5 to both sides? No, yeah, add 5 to both sides. The left side? Right, so add 5 to both sides. So that would be what? 6x plus 12 equals 8x, right? And the addition. Okay, then what?
Subtract 6x.
Subtract 6x, that gives me 12 equals 2x. That's subtraction. Okay, then what? Divide, so that's 6 equals x, that's division. And then what? Use the symmetric to flip it, right? Alright. And again, you could have solved your equation a little bit differently than what Samson decided to do. Okay? What Samson decided to do. Alright. Okay, let's look at this one. Now, you might solve it a little bit differently than I think is easier to solve. So I'm going to enlighten you. If you were given this, what would probably be the first thing that you do? Get rid of the fraction. You say distribute. If I distribute it, I'd have some yucky fractions, right? When you say get rid of the fraction, how would you get rid of the fraction? Okay, he's saying multiply both sides by 9. And yes, you could do that. Okay. And that's what we did in my last hour. And I could do it that way. It's a lot more steps. What happens when you multiply a number by its reciprocal?
Like by its
No, by its reciprocal. What's the reciprocal? Flip it, right? Okay, so if I take 3 and multiply it by 1/3, what do I get? 1. If I take 2/3 and multiply it by 3/2, what do I get? 1. So if I take 5/9 and multiply it by 9/5, what am I going to get? 1. So it might be easier if I did that. If I multiply both sides by 9/5, then what I end up with is the 9/5 C equals, these cancel, F minus 32. Okay, and that would be multiplication, division. Well, you could say either one. Because what's happening is you're dividing by 9/5, but when you divide by a fraction, you actually multiply by the reciprocal. You remember that from 6th grade? Okay, sure you do. Alright, so I'm still trying to get F by itself, okay? And so what would I do?
Well, you could subtract F.
I could, but I want to get F by itself.
Plus 32.
And I would add 32 to both sides. So that would be 9/5 C plus 32 equals F. And that would be addition. Okay? And then what would I do?
Then you can
Reverse it. What's that called? Symmetric. So F equals 9/5 C plus 32. And you would get the symmetric. Now, if you're not comfortable with that, you could have multiplied both sides by 9 and then distributed the 5. You would have gotten the same answer. It would just take me probably about 4 or 5 more steps. But that's fine, because as long as you get there, that's what counts. Okay? All right.
So